Okay, my friend, another fabulous day in MFU land. And this is Roger, and today I got this from a physicist who, I'm going to read it to you. As physicist, I worked at the CEA Atomic Energy Commission in France during the 60s and met Professor Louis Curvan, which became his mentor on a project I had already in mind and that I performed in the 80s, the production of natural fertilizers directly from seawater. Now, he says as an agronomist, engineer, and physicist, he specialized in biological transmutations at weak energy. Now, that is what I'm interested in. Since several decades, he worked as a freelance consultant, advanced technology, international companies, governments. Example, he worked for Chinese experts at Zhuhai Special Economic Zone, launched several projects, and I have personally designed and perfected several disruptive technologies and processes, clean energy, and biological agriculture. Now, this guy knows what he's talking about. Now, one of them is the production of liquid fertilizers directly from natural seawater. And natural seawater contains all the elements that are in the human body, and all the elements that are in the human body are all the elements that are in organic nutrients. So he says, mud fossils do not take millions of years to form. They can form very rapidly. Yes, I've done it myself. And the waters prevailed upon the earth in 150 days. Now, I made them myself here it was less than a year. And it's a natural, there's telluric electrical currents that are in the earth, and they run through the waters and the moisture in the earth. And that literally plates them on their surface, and then as they get coated with mud, they are protected, and the outer casing, once all the organic stuff goes into solution, it doesn't explode, and now it starts to dry out. So this Curvan's effect is, yes, I agree with this. I'm not sure necessarily about the mud fossilization of it, but the Curvan's effect of transmutation, yes. Now, transmutation is a little different than I believe what I have found in mud fossils. Mud fossils is stability of minerals, because once all of the volcanic volatile organic compounds, the gases and so forth, go away inside the waters, you end up with a lump of tissue. And that just it stabilizes in whatever, bonding and so forth. Well, not necessarily transmutation, but what he's talking about here, this Curvan's effect, is true transmutation. And they proved it because the calcium, or was it potassium? Hold on. I gotta get my periodic chart. Yeah, we went from potassium up to calcium. It went from potassium up to calcium. And the way it did it is, this is like a 39, this is 19, and this is 20. The 19 picked up an additional hydrogen to make it up to the 20. And he's got all the formulas and everything in the papers. But this is fabulous information. And this person knows what they're talking about. So, and this is the article. Now, and goes back to 1981. This is a problem. They say, we got to have this peer reviewed this and that. Well, they do it, but then they just put it on just forget about it. And this shows, here's the potassium moving up to calcium by taking on a hydrogen. Now, they did this by putting plants in an environment that had no calcium, and it moved from the potassium into the calcium. And everything can transmutate. And bacteria is the things that transmutate them. I'm sure that there's some form of bacteria in there that did that job of attaching a hydrogen to that potassium and creating a calcium. That's in my world, I'm almost certain. And it changes that certain amount of weight, which is a couple of, let me see, 0.04. That's like 2. Okay, I think I figured out what happened with these electrons. This changes it by a weight of 20 extra electrons when it jumps. Now, that's a key, because there's 2 different things that happen. Anyway, we're going to get into this deep. All right, and I realized something from long ago, I think started to make sense to me, and I'm going to just quickly explain it. Okay, my friends, we're going to have a very short one today. We're going to start into the depth of chemistry and everything about molecules and atoms. And you say, well, Roger, why are we starting here with burns in the medicine? Well, I will explain it to you. Because that is also chemistry. So let's say, here, let's start with the summary. A burn, we all know what a burn is. It's damage to your body's tissue caused by heat, chemicals, electricity, sunlight, or radiation. Right? What are all those things? Caused by heat, chemicals, which are primarily acids, electricity, sunlight, or radiation. Well, guess what? Every one of those things has in common. They're all electrons. And I'm going to explain you to this. Now, let's just start with this. What causes burns? What is hot and cold, really? Hot and acids burn. Hot things and acids burn people. Why? Hot gets cold. So, in other words, I've got this thing here. It might be 200 degrees. I can't touch it. It's too hot. But then it will get cold. What left it to make it get cold? Still the same rock. Cold gets hot. What do you add to this to make it hot? Something leaves to make it cold, I would assume, or something cold goes into it. But I would say that it's not that way. Something leaves to make this cold, and something comes into it to make it hot. Now, why does sunlight add heat? Why does concrete get hot? All right, we're going to go over all those things. And they all relate to the periodic table of elements and to the actual construction of atoms, which they never understood and they do not understand today. And I came into something today looking through my ancient stuff, which I always had a trouble with heat and a calorimeter calculations I did so long ago, like 50 years ago, when I first started into this, and I just figured out what it is. It's ether caused my calculation error. All right, this goes way back. This is one of my first, well, I think this was my first book. And I was doing calculations on heat and changing and the solutions and all of these different calorie changes and all that stuff. And then I ended up having this. The conclusion was something was missing. Something was missing in the electrons. So I reasonably valid because of the styrofoam cup, which is an insulator. If the temperature of the calorimeter was the same as the distilled water, it would eliminate most of the errors. And anyway, I went into some details and I said that's too involved. And then I came down here with what I believe is the actual situation. Another possibility of the error is a copper cooled slightly before getting into the calorimeter, and I believe that's the case, but it was the electrons moving into the ether. I do understand it now.